Hello everyone, welcome back to our oceanography. In today's session, we will be knowing about the relief or the morphology of the bottom features of our ocean. So let's move into our topic directly. What is an ocean floor? The floor on which the ocean water rests or lies, we call them as an ocean floor. There are large varieties of features on the ocean floor which are different from one another depending upon their depth, slope, etc. Hence, the relief of the ocean floor is broadly divided into two categories. Let's look into which are they. One is the continental margin and the other one is the deep ocean floor. What is a continental margin? The part of a continent that extends into the sea, we call them as continental margin. The continental margin consists of four important relief features. We can see those features in the diagram. First, the continental shelf, then a steep slope known as continental slope, then comes submarine canyons, and then continental rise. So, we will be studying all these features in detail. What is a continental shelf? A continental shelf is a zone around a continent that extends from the line of permanent immersion to a depth at which there is a marked increase of slope to greater depth. So, if we are going to tell in a simple word, we can tell that there will be a part of the continent that is always submerged under the ocean water. We call them as continental shelf. So, part of our continent which is already submerged under the oceanic water is known as continental shelf. That means that this continental shelf will be generally with very less depth up to a region where a sudden slope increases. Those areas will be categorized or considered as a continental shelf. According to the deposition of the sediments, the continental shelf is divided into two, or they are formed as a result of two types of deposits: the glacial deposit and the fluvial deposit. The glacial deposits are formed as a result of the action of glaciation. At the same time, the fluvial deposits are formed due to the action of river. At present, the continental shelf comprises of 6% of the total area of our Earth's surface. So, this diagram shows that where the continental shelf lies with less depth and up to the region where there is a marked increase in the slope. The average width of the continental shelf is from 65 to 78 km and it has an average maximum depth of 133 meters at its margin. The width of the continental shelf generally depends upon the slope of the adjacent area. That means if the coastal region is a very plain area, means the continental shelf will be several miles in width. At the same time, if our continental shelf region or the coastal region is a hilly or a mountainous area, means the continental shelves will be very narrow. At the same time, they are very deep. And majority of the onshore fishery activities took place in the continental shelf region, especially where it is very narrow and deep. Most of the major cities of the world, harbors, ports, tourist centers are located under such areas where the continental shelves are very narrow and deep. The wide character of the continental shelf is due to its wide depositional sediments. These deposition took place in a layered manner such that it leads to the compression of the lower sediments by the upper sediments. So what happens when more sedimentation takes place? It will lead to the compression of the lower sediments by the upper sediments, and this results in the formation of sedimentary rocks. If these depositional areas have large amount of humus content in earlier days means when the sediments will be compressed, these areas will become large reservoirs of petroleum. So remember that if such areas is having huge humus content, the compression of the lower sediments by the upper sediments during the process of sedimentation will lead to the formation of petroleum or the crude oil reserve. The boundary of the continental shelf on the ocean side is determined by an abrupt or a sudden change in the slope and a rapid increase in the depth, and that area will be called as continental shelf break. Now we will move into what is a continental slope. Continental slope is a steep slope that extends from the continental shelf break that we have already discussed, that a sudden or an abrupt change in the slope over the continental shelf region where the depth will be increasing rapidly. So from the continental shelf break to the ocean basin floor, the steep slope region we call them as continental slope. So in this diagram you can see that in the beginning there is a continental shelf or the part of the continent that is submerged in the ocean water, and thereafter immediately there is a sudden decrease or increase in the slope of the region to a greater depth, and that slopy area we call them as continental slope. According to erosion theory, the continental slopes are generally formed due to the erosion by the marine processes, especially by the sea waves. At the same time, in the tectonic theory, they believe that faulting or the faulting activity is held responsible for the origin of continental slope. The angle of the continental slope always varies from 5 degree to more than 60 degree at many places. The depth of the continental slope also varies from one place to another. It may vary from 200 meter to 2000 meter. Because of the steepness of ocean floor in this area, it is a highly erosive zone. As a result, ocean current always passes through the continental slope area. So remember, it is through the continental slope area that our ocean current almost passes. Since these type of currents are having very high amount of sediments, they will be flowing as a subsurface current due to the heavy weight of the sediments. So we know that this part is a highly erosive zone, and hence they will be having or they are always sediment laden flow of water, and due to the heavy weight of the sediments, the ocean currents always flows through this region as a subsurface current. And such type of currents that flows according to the gravity, we call them as turbidity current. And this turbidity current will take sediments away from the continental slope. Hence, we consider this region as an erosive zone. And presently, the continental slope occupy about 8.5% of the total area of the ocean basin. The most extensive continental slopes are found below 20 degree north to 50 degree north latitude and between 80 degrees south to 70 degrees south latitudes. So these are the regions where the continental slope regions are more extensive or found more than any other parts. The third part in a continental margin is known as continental rise. So at the base of the continental slope, what happens is that continental slope is a highly erosive zone, so that all the sediments will be taken away from this region, and at the base of the continental slope, like our foothills during a river action, the steep gradient of the slope gradually will be decreasing to 1 degree or less, continuing into abyssal hills or plains. And this portion of the sea floor with very gentle slope, with much amount of sediments, we call them as continental rise. So continental rise is the product of the underwater landslide or any other process that carry sand, mud and silt down the continental slope. The continental slope is a very conspicuous feature in Atlantic and Indian Ocean. It can be also found in and around the Antarctic continent. So in the diagram you can see that in the beginning there is a continental shelf with very gentle slope, and thereafter the continental shelf break occurred where a steep slope started, and this part we call them as a continental slope area, and at the foothill or the base of the continental slope the gradient of the slope or the steepness of the slope again comes down to 1 degree or less than that, and that region is the continental rise area. The last feature in the continental margin region is that of submarine canyons. So what is a submarine canyon? You know the word what is a canyon, that what you have studied in your fluvial action of the river. Similarly is the concept of a submarine canyon. Submarine canyon are deep gorges with deep valleys and steep slope on the ocean floor. So they are similarly like that of gorges with very deep valleys and steep slopes. Some canyons will also terminate in a fan-shaped cone or deltas on the seafloor. How the submarine canyons are being formed? When the turbidity current has been flowing continuously, where in the continental slope areas, and then it will come down near to the continental rise area, the fissures in the continental rise area will start get widening, and then that widened part finally leads to the formation of deep gorges with deep valleys and steep slopes, and thereby the submarine canyons are formed. Thus, the submarine canyons are the most important relief feature on the ocean floor. Do you know which is the best known canyon in the world? It is the Hudson Canyon, which begins near the mouth of River Hudson and extends into the Atlantic Ocean. You can see a satellite image of the Hudson Canyon in the diagram, and the largest canyon in the world is not the Hudson Canyon. It's found in the Bering Sea of Alaska. So, with the continental shelf, slope, continental rise and submarine canyon, the continental margin part is over. Now, the continental rise has now extended to the next feature called as the abyssal plain or the deep sea plain. So, from there, the deep ocean floor has started. So, what is an deep ocean floor? The ocean area that extends from the base of the continental rise to the deepest point, we consider them as the deep ocean floor. The deep ocean floor covers about 76.2% of the total oceanic area. The deep ocean floor has the following features inside it: the abyssal plain, the abyssal hill, seamounts and guyards, ocean ridges and rises, ocean trenches and deeps, and the island arcs. Let's look into all these features in detail. What is an abyssal plain? Abyssal plains are tectonically inactive areas of deep ocean floor having a flat bottom and very gentle slope. They are generally about 1000 km wide and situated at a depth of 3 to 6 km. Abyssal plains are surfaces formed by long continued deposition of very fine sediments, and hence therefore they are having a nearly perfect flatness. In this diagram, you can see that how an abyssal plain looks like. They are almost with nearly perfect flatness because they are only deposited with very fine sediments. These type of abyssal plains are situated at the foot of the continental rise. You can see large number of abyssal plains in Atlantic and Indian Ocean. At the same time, abyssal plain is very few in the Pacific Ocean. The abyssal plains are also known as deep sea plain. And these type of regions are completely absent of any sediment deposits brought by the rivers. So remember, the river or the action of the river or the sediment deposition of the river takes place only till the continental rise area. The deep sea plains are generally completely devoid of such type of sediment deposits brought by the rivers. What is an abyssal hill? Relatively small hills that rises around 60 to 1000 meter height from the abyssal plain. We call them as abyssal hills. In the diagram, you can see small type of hills with a height of 60 to 1000 meter from the bottom of the abyssal plain. They are generally up to 10 km wide and are circular or elliptical in outline. These abyssal hills are generally associated with our oceanic ridges. Abyssal hills cover about 50% of the seafloor of our Atlantic Ocean and 80% of the Pacific Ocean. They are also abundant in our Indian Ocean. Seamounts and guyot. Seamounts are isolated steep submarine volcanic features which are generally 2 to 100 km in wide and less than 1000 meter high above the seafloor. So they are similarly like a volcanic feature, but they are found in the ocean floor with a maximum height of 1000 meter from the seafloor. Sometimes some seamounts will be rising abruptly above the sea level. So we can see some type of seamounts that will be found above the sea level, and that type of seamounts are called as islands. You can take the example of our Hawaii is a perfect for a seamount that rose abruptly from the sea level and known as the Hawaiian Island. Sometimes some seamounts have a very flat top, and such type of flat topped seamounts we call them as guyots, and these type of features are very common in the Pacific Ocean. So in the diagram we can see a seamount that rose abruptly from the submarine ridges or from the deep ocean floor, and some of the seamount has arose even abruptly above the sea level, and those type of features we call them as volcanic islands. And due to the erosion process, what happens is that the top of the seamounts will get eroded and almost it looks like perfectly like a tabletop, and such type of flat topped seamounts becomes or forms into as guyots. What is an ocean ridge and rise? The most remarkable feature on the ocean basin floor is that of the ocean ridges and rises. And these ocean ridges and rises cover about 23% of the total surface area of the earth. How they are formed or where they are formed? The ocean ridges and rises are usually formed in the zones of tension where the plates converge. So we can find the ocean ridges and rises in the zone of plate convergence. The active spreading ridges are generally about 1000 km wide and 1000 to 2000 meter high. If the slope of these ridges are very steep, we will refer them to as ridges. The best example of such type of ocean ridge is that of Mid-Atlantic Ridge. At the same time, if the slope of these areas are generally, or the swells are generally gentle, we will refer to them as rise. You can take the example of East Pacific rise. One of the most remarkable discovery in the mid-20th century was the great submarine mountain chain that extends for a length of somewhat about 14,000 kilometers. And this is known as the mid-oceanic or the mid-Atlantic ridge. The mid-Atlantic ridge even has a width of 2000 to 2400 kilometers wide. And we will be discussing in detail about this mid-Atlantic ridge or the mid-oceanic ridge while we study the bottom morphology of the Atlantic Ocean. So you can see that how long the mid-Atlantic ridge is extending, around 14,000 kilometers. Perhaps we can consider that this is the longest mountain ridge in the world. So we will be moving to island arcs. What is an island arc? Island arc is a chain of volcanic islands. They will be almost looking convex towards the open ocean and then runs parallel to ocean trenches and mountain chains. So an island arc is a chain of a volcanic island which is generally convex towards our open ocean and run parallel to the ocean trenches and mountain chains. They are generally formed by the convergence and collision of two oceanic plates. We can take the example of Mariana Island, Lesser Antilles, our Indonesian group of islands, island arcs. All those can be taken into consider as an island arc that are formed as a result of the convergence and collision of two oceanic plates. So you can see an example of a part of the Lesser Antilles in this diagram. Apart from this, you have one more feature which is known as ocean trench and deep. Most of you might have heard about the word the Mariana Trench and the Nari Deep, the deepest point on the earth, the natural point on the earth. So what is a trench? A trench is an arc-shaped depression in the ocean floor and which is generally about 30 to 100 kilometers in width and have a depth of 6,000 to 11,000 meters below the sea level. They are the most active geological features on the earth. Hence, they are also called as submarine trenches. And you know, the deepest spot in a trench, we call them as the ocean deep. And these ocean trenches and deeps cover about 7% of our ocean basin floor. So with this, the major features on the relief or the major relief of the ocean floor is over. In the next session, we will be studying in detail about all the bottom morphology of the major oceans of the world. I hope today you have enjoyed the session. For any doubts, you can refer to my Edmodo account. Thank you and have a nice learning.